In this section, we will talk about forecasting in general, what it is, what it means to companies, as well as discuss some insights and good advice from successful forecasters in the business. I wanted to start out with this. It is actually based on a sidebar in your book. I could not scan the sidebar, so I looked for the original article, which was published in 2001, and it details forecasts made by scientists for the adoption of satellite television. The forecast was made in 1992 at the order of DirecTV, and then they made the forecast. They made their actual observations, compared to two for about 5 years, and then they put it all together in this publication. The tool that they used for forecasting is known as the Bayes model. It is an application of differential equations, so in terms of quantitative level, it is more sophisticated than anything we will learn in this class. But it is related to our idea of a life cycle analogy, and it is a quantitative application based on that, and also it's an example of how these companies actually have to do it in real life and how successful they can be. So I felt it was interesting enough to share. The model is based on the assumption that when a new technology hits the market, innovators will embrace it, and then as they are getting bored with it and moving on to the next hot thing, they will have started off imitators that will start gaining in numbers and after a while level off and start to fall. And the model actually quantifies these movements for a given technology and comes up with forecasts for adoption rates for satellite television. And this is a graph from the article where the straight line is the forecast that the scientists in this project made, and the dotted line is the actual observed values. So this is amazing. It's a good example of bias. As you can see, they consistently underestimated the growth of satellite television, but at the same time, it is remarkably accurate in their seeing how the line was going to be changing its slope and how the adoption rate was going to grow over time. So, in general, forecasting is the process of projecting the values of one or more variables into the future. And you can do operational forecasting. You can be, for instance, running a grocery store and asking the question, how many gallons of milk are we likely to sell this next weekend? When you consolidate that over a number of products, over a slightly longer period, over many geographical regions, you have aggregate forecasting. And then when you extend the time horizon even further and try to look further into the future, you have long-range forecasting, in which case you probably will be relying more on judgmental or qualitative forecasting methods. This is a great example of both long-range and aggregate forecasting, so I wanted to share it with you. And it is from Boeing Corporation trying to forecast the demand for different types of airplanes over the next couple of decades. And as you can see, Boeing is assuming that people will want more efficient point-to-point flights, so they are kind of banking on, they are kind of forecasting that there will be more medium and small airplanes being commissioned by airlines and fewer large airplanes. Now, this is remarkable in that Boeing's biggest competitor, Airbus from Europe, is actually forecasting just the opposite. They're forecasting that with increasing fuel prices, people will only take airplanes in very large planes going from hub to hub, and then maybe go by road or by train to their final destination. So they are forecasting a larger use of larger plane. And it might be that they're simply segmenting the market, but it's also possible one or the other of them are wrong in their longer range forecasting and will emerge as the winner in this industry. So you could pick an industry like this for your final paper and try to see how they're doing their forecasting and write a very nice paper based on that and maybe tie it to other operational decisions. The important point that I'd really like to underscore here is that forecasting is necessary for every aspect of a business. In marketing, you need to forecast your demand, your likely sales, what technology is coming in. Based on that, the finance people need to forecast what financing needs are likely to emerge to get those technologies into the company. The production managers, the store managers need to be doing operational forecasts, scheduling their workforce, scheduling their inventory according to that. Maybe at a longer range, they need to be forecasting or reading forecasts of larger economic indicators so they can do larger, longer scale capacity planning decisions. And then you have to, on the service side, be able to forecast things like how often or how many customer complaints you're going to get, or repair needs in your maintenance department at your factory floor or your store that you're going to get. So nobody can say, I'm not doing forecasting. And the better you're trained to do this, the more successful you will be. That includes an ability to crunch numbers, or at least use the tools that you are handed in your future careers. But it also includes an ability to then stand back and use your insights and know when you need more information, know when you cannot simply blindly keep extrapolating from the past. So different kinds of decisions are going to need different time horizons. As you can see, capacity planning, which we have discussed, process design, which we're going to move on to next, requires longer time horizon forecasting, whereas inventory management, for instance, that we'll go into later in the semester, requires a shorter time horizon. So in general, planning horizon is what we call the length of time for which you're basing a forecast. And it's possible that you're dividing it up into buckets. So it's possible that you're saying, I'm going to be making 20-year forecasts, but I'm going to look at this in 2-year increments. But regardless of how you're approaching your time horizon, the longer the time horizon that you're trying to forecast, the lower your forecast accuracy is going to be. We'll talk a little bit more about this later. So the important thing is to pay attention to the difference between interpolating and extrapolating from a given model. Consider a time series based model. Consider something like you created a trend line. If you are trying to then use this trend line to harken back and guess at what happened sometime in the past, your model will probably be fairly successful. If you're extrapolating only a little bit into the future, again, unless a big cataclysmic event occurs, you'll probably be fairly successful. But if you try to extrapolate very much longer into the future, you are likely to be making mistakes because the environment shifts. This is my favorite extrapolation graph, and it is somewhat funny, so I'm hoping it will stick with you. But you cannot say this person's height grew from like 2 feet when he was really, really young over to like 6 feet when he's in his late teens, and therefore he's sure to be 10 feet tall by year 30. People actually do this. They don't do it about each other's heights, but they do it about the success of their products, about how fast their sales are going to keep on growing. So it is very important to pay attention to your forecast horizon and to be more conservative in your forecast far into the future or far outside of the range of the causal variable for which you have built the model, and also to keep repeating forecasts. Do it, look at your errors, shift a little bit, change your model, taking in the new values of the data, do it another time again.